Thanks for attending. How you doing at AWE?
Man.
So we're here for ExxonMobil's Digital Reality Ecosystem project and how we're moving the corporation to a visual way of working. Don't need to focus on the big words. Focus on the little words, moving to a visual way of working. Hopefully by the end of this presentation, you'll understand what we mean. My name is Athicha Dhanormchitphong. I go by M. I'm the Digital Reality Ecosystem Architect. 20 years with ExxonMobil, where 10 years was in R&D, and the other 10 years was in development. Switch that the other way around, though.
My name is Daughtry. Folks just call me Kyle. I've been with Exxon about 17 years, a bunch of different digital and technical roles. Like we mentioned here, I'm the Digital Reality Strategy Manager.
All right, it's a lot of work, and it's coming up to this project now, so we need to give you an overview. Some of the folks in the audience are very well aware, but we always want to give the respect to other folks that have not heard about this project, right? So you're going to be drinking from the fire hose and give you an overview and a recap of the project, followed by what are our foundational efforts, right? So you can actually understand our processes. And then from there, we'll breeze right through use cases in action. That's probably the part that you guys want to see most. We have a video, so we'll show that at the end, but we'll just run through it real quick.
Context is king.
Yeah, and then from there, you understand why ExxonMobil has chosen reality first. We'll close it up with a call to action.
All right, start that overview part. What is this digital reality ecosystem? Essentially, what we're seeing this is, how do we bring higher level of context to folks in the field at the right time, anytime, right? And really trying to shrink the gap between the digital and the physical world. And this heavily comes together with spatial computing and visual data, and we'll talk a little bit more about that. But to hit on data, right? One of the things we first learned at the very beginning was I can go find a provider to instantly deliver me a digital twin, spatial computing, all those kind of things. But the fabric behind all of it is information. And we are focusing on how do we make it modular to system, open integration, agnostic to platform and based on industry standards, or a mouthful for saying, how do we make this not monolithic?
We paid that bill before. Remember the 10 years of research and stuff like that? We were mapping out our learnings. And our executive asked us one day, well, what is that root cause? And we had to zoom out. Look at those words on the bottom of that spaghetti diagram. Single use. We used that data just to make a decision, and it was forgotten. And a lot of those times we started zooming out and just realized we're pretty siloed out. For those folks that work in enterprise or even understand that, do y'all feel that same pain as us?
Show of hands. Yeah.
All right, awesome. And so really it's broken down by capture, store, deliver, consume, but each pillar of those within the ecosystem was a major mess. We didn't understand how we were capturing. There was no centralized storage, right? We didn't understand translation or delivery of that mechanism. And the use cases were out the wazoo, and oftentimes, again, single use, married to applications.
So M got to show the chaos. I'm going to show you where the current state of our ecosystem is. M mentioned this breaking down, capture, store, deliver, and consume. It's really a novel approach, but it actually has helped the corporation look at information across the life cycle, not just in this visual aspect, but even other particular spaces. We'll focus on the visual and hit on a couple of key components. So number one, in that capture space, how do we democratize capture? What we mean by that is how do we actually provide the right guardrails, guidance, and global practices for sites to be able to go capture their data, whether that's from an EPC delivering them models or it's from scans in the field. To ultimately, where we're trying to get to is bringing together your iPhone and getting high-level contextualization in the field as fast as possible. The hard part there is how do you bring that all together into one spatial world, which leads you into that second part. Again, we mentioned it at a high level, we're focusing on how do we separate software from data. So how do we actually bring together all of this spatial and visual data with the rest of the context of engineering, inspection data in the world, but do it agnostically. We were bold saying that there wasn't something out there in the industry, and we've been partnering up to make that a reality. 3, how do we allow plug-and-play integration to systems? Ultimately trying to get to this point where we can consume information anytime, anywhere. And that's not just for devices like headsets, phones, tablets, PCs, all of that good stuff, but also for particular use cases, right? Engineering use cases are going to be different than emergency response use cases. Training use cases are going to be different than turnaround use cases. And they're all going to work in this ecosystem together. One of the great things that we've done so far is actually made this a reality. Ultimately, the biggest part to this is how do you actually capture what, when, where, and why, and make sure that there's an actual digital thread that stays through the life cycle to enable us to reuse many times. So from training to operations to turnarounds to emergency response, all data used repetitively.
We're not asking you to throw it away anymore. We're asking to create a recycling bin to reuse that data, right? Data, like Kyle mentioned. 255 definitions of a digital twin, according to a military white paper. And ExxonMobil internally, before we had this Venn diagram, we were constantly writing internal white papers about this is our definition. This is what we must do. I think we finally nailed it down to this Venn diagram, how we shape that data, the definition of that data for a digital twin. And really it's broken down into 3 components. Visualization, top right, the aggregated data, and then basically the analysis, simulations, or modeling. I'm going to give you a real-world example. It's in your pocket right now. How many of you folks use Google Maps or Waze? Awesome. Actually had to do that this morning as well, too, because we're from Houston, Texas, and first time in Long Beach, beautiful place. We didn't know how to get here. Visualization, that's the road you're on. In this case, it was the hotel where we started, right? The data aggregation told us, well, here's the red lights, right? Here's the traffic flow rates, things like that. And the analysis and simulation piece was based on historical data. Well, if you're going to walk there, or even if you're going to take a car, we predict it's going to take you this long, right? From where you start and where you begin, or where you ended. And at the healthy center is that definition or that data for the digital twin for ExxonMobil.
Last thing I'll put in there is that not every asset across our globe is going to hit towards the center, but one of the things that we're trying to do is move things as close as possible towards that center to be able to bring context. Again, context is king.
And keep in mind, too, you don't always need to hit the healthy center.
Yeah.
Right? If the use cases will drive that. You might just need a visual twin. You might just need a data twin.
All right, so this is just a conglomeration of an asset lifecycle for us. This might seem familiar for other enterprises on how you go through design and construction, and during that phase, you'll have a lot of engineering data. You'll have a lot of drawings, you'll have 1D information, you'll have 3D models that get delivered. You'll also do some reality capture towards the end of that construction project to do verification in the field, right, to make sure that it actually is fit up in the real world. Then, in our particular world, the dreaded handover comes into play. And we lose that information in a lot of the cases of regulatory requirements for how do you actually manage integrity management to why do I not have my 3D model throughout the life cycle. So one of the biggest focuses here for us was not just the technology part of it, but the actual process part to make sure we had handover effective. Because at the end of the day, if you look in operations and maintenance, that gap gets filled no matter what. Either I'm going to do it now and transfer the information, have no cost to myself, or I'm going to go do it again and again and again, over and over and over again. This is probably one of the best representations of that process problem and the actual technology problem to potentially solve it.
So remember that future state that Kyle showed with the animation, how that data flow from between
3D
capture,
animation.
store, deliver, and consume? Excuse me. Foundational efforts really falls in the first 3 pillars: capture, store, and deliver. We'll always be working on that. It's an emerging technology. We'll always need to understand exactly, well, what are our standards? What's interoperable, right? How do we communicate that across sites? Our storage, Kyle's mentioned we partnered up with some big majors out there, right? That's something that we're continuing to build upon and making sure our APIs are always updated. Translation, we got to understand that and how we deliver that to our consumption platforms. But the use cases on that far right, that's always going to drive our consumption. It doesn't have to be a VR headset, doesn't have to be an AR headset, it could be an iPad, it could be a phone, it could be a web-based thin client. But those use cases is really what drives that. And we take MTech's DIA process, discover, incubate, and then accelerate at scale. We are a global company. We cannot have siloed out use cases. We must have integration across the world. And so what we do is we discover those high-value use cases. From there, we incubate them at a site. And once the checks have already came across the systems, we scale it across.
All right, so we're going to speed up a little bit here because I want to get the context. Again, context is king, and the video is probably one of the best things you're going to see. There are two different areas inside that foundation, so go to what Em mentioned about foundation part, that we saw missing in this visual and spatial data world. And again, that's been a lot of our big focus right now is how do you build agnostic storage for 3D content. We were pretty bold out there for a while to say that there wasn't a platform. Again, now we're working towards something that could be true. Geospatial data. End of the day, everything is spatial. Space and time governs pretty much all of the context that we're building inside of our world. So we want to make sure we actually capture that and reuse it across all types of platforms. Again, we mentioned the aspect of using it for training, but also using it in a turnaround event. I need to know where that compressor is and the operation statistics of that compressor at all times. To be able to do that, I have to work across many different systems. That was another area that we saw that was missing, right? There was an aspect of how do we actually build spatial data that goes across all systems. Again, partnered up with an interesting set of folks inside of this industry, and we're hoping to push forward on that as we go forward.
Use cases.
Fast.
All right. He said fast. I'm going to go fast.
Jim Johnson.
You see it in the video. We use it for easy navigation familiarization, all on Google Earth. We overlay it on top of 2D diagrams to give us more context. We use it for planning and scoping. Let's take the Z-axis, let's take the measurements, right? We use it for turnarounds and logistical planning. The fact that you can overlay on top, you can do different layers with contrast. Projects, integrating CAD with point clouds. And then from there, working visually to understand what's within tolerance with that, right? We send drones up in the air to give us visual inspections and use AI to give us basically the anomaly so that way we can focus. From external, in the air, we go to internals as well. And then from there, we reuse that data for training and immersive technologies, connected workers, and things like that, and even breaking it down to augmented procedures in the field. Keep all those in mind. I know there was a lot.
It's a lot.
See it in the video, I promise.
Okay. All right, so I want to hit on one big thing that was paramount for us. There's this shift for us to what we're calling reality first. So if you kind of look at your asset life cycle and what gets delivered, you've got this CAD model, you've got a bunch of engineering information that feeds into it, and then once you go to operations, all that engineering information goes out to other systems. And you have some level of context, right? You also have your ERP systems that pull in a lot of information about that site. But honestly, look at that CAD model and then start looking at the green and the orange and the blue. That level of context is what you get in your ERP systems right now. Now, it varies depending on process at the end of the day, but that level of context is what you're going to get in space and time. This is the same area scanned down to 1/8 of an inch. And the beauty is, over the last 3 years, the cost to be able to do this at scale is 10x reduction. So you're going to see that in the next 3 years, the same thing is going to happen. Us being able to manage reality is actually going to become faster, and it is right now faster than being able to
Think of your
manage
consumer world. You're looking at reality all the time. So trust is a big deal. And our engineers and our operators, that was one of the major feedback across the site is, I still don't trust that data. I still go out, I still go walk it.
But
Think about the cost plus environment from scan to BIM as well. We're not saying don't do that. Just do it where it makes sense. But the fact to take a picture, a snapshot in time, what Kyle was talking about is it's here, it's cheaper, it's faster.
But again, context is king, right? Bringing in context from the real world. So you're going to ask the question, oh, I don't have any context around my engineering information. What we're finding is being able to pull together space and time, all that information. So CAD on projects we have it, reality, and bounding boxes on ones that we don't, and storing all that information in space. So that compressor or that exchanger has all the information that's needed from engineering, but not trying to govern it off of just a model, governing it off of reality. essentially moving to reality first.
He talked about location. The minute I move, my location data has already
Location's everything.
changed. And there is a lot of great work inside ExxonMobil. And what we're trying to do with this project is to disrupt that location data, to seamlessly integrate it from parcel level to units to assets all the way down to component. We're doing a lot with some other majors in the background, but just be aware that to really have that data to be trustworthy, we need location data as well.
All right, so we've gotten through the overview. We talked about the foundation, talked about reality first and all that for us. Now this is our ask to the industry, our ask or call to action. Really, we see two different things, two different paths. One, come join on that journey of separating software from data. I think most folks in the industry will recognize that that's the only way that you're going to be able to bring this to scale, is being able to use your data anytime, anywhere. Second part of that is join the journey and let's work together through industry groups to be able to actually make this a reality.
Data's our oil, and you can't do it alone. You can't go back to the EPCs and the third parties and say, hey, ExxonMobil alone is doing this right, but we share the same problems. We need to come together as a collective voice.
So we're going to hit on a couple of industry efforts that we're working on right now, and there's many more, but we wanted to give a little flavor of what's going on. So one of them is this work effort called OADT, the Open Asset Digital Twin. Through ARC Advisory Group, we've actually pulled together most of the majors in our industry to give a singular voice to the industry, suppliers, EPCs, and saying, what do we need to focus on to be able to make this information agnostic and open? There's been a journey since 2020, 2021, and we're going to continue to extend that. But you can see all the majors and some of the focus areas. I won't spend a lot of time on the words. But what you also see is that we've been able to pull together what are the problems within the industry. And this is not just from owner-operators like ourselves. This is from suppliers, along with our contracting EPCs. And it's unanimous, right? The cost of maintaining a digital twin is high, way too high. There's a lack of expertise within 3D, but also processing models in general. Poor and inaccurate data quality. If any of these things resonate, raise your hand, right? Does this resonate within most industries? Yeah, we feel the same. If you could, scan that QR code. It'll bring you to a survey to fill out some information, but it'll also get you into a contact to that working group. ARC has been great to work with so far. You'll be able to meet up with Mark from there. I'm going to skip this part, but again, industry only moves together whenever you are together. So we're pulling together all of these different consortiums along with professionals within the industry like ourselves.
Digital Twin Consortium, and obviously the Augmented Reality Enterprise Alliance. Those are the other two groups that we're a part of as well. Really, it's part of not only just interacting with our industry, but it gives us an opportunity to understand and learn from adjacent industries. Different definitions, but how do we utilize this technology? We all face the same challenges and the same problems. Look at the breadth of basically that consortium. And
You
that's
probably
one of the
can't see it
reasons-
as super small, but it's almost every industry.
Yeah, pretty much. You get exposure to quite a few things. You learn quite a few things through these member meetings. There's digital twin capability toolkits, as Kyle showed, and user guides and so forth. We just wanted to give them a shout out. Dan Isaacs, as well as Mark Sage, has done a really good job, really pushing these things out there for the community. And so I want to give them a shout out for that as well.
All right. So we went through that laser fast, but we wanted to give you a video to give you some perspective on what we're working on.
We're trying not to get booed off the stage.
Let's see if the audio
before
works.
we run out of time. So,
You guys have audio on your side?
no, there's no audio.
Should I try it again? Yeah, it shows it. Hold on one second. Maybe we'll go to speaker like that one. Nope. Of course, technical issues. You still don't have audio on your side? It looks great, right? Yeah, it looks wonderful.
I guess while he's figuring that out, the footage is what we're using inside ExxonMobil. And hopefully you guys understand,
Okay.
right? It's a data play, providing contextualization where we need it, choosing reality first, right? So that way, at the same time, we can build that trust.
Because Decimator will be your HDMI.
Sure, yeah. Happy to.
That's not.
That's what I want. That's what you're plugged into. That's what you want. Thank you.
Nope. Nope. No audio.
It's got to be on headphone now. Yeah, it's on headphone now.
Yeah, that's a Bluetooth headphone.
Oh, that ain't right. Speakers. No, that's LP.
I could put my mic up to it, and you guys can hear it from here. Yeah, you want to do that? All right, here we go. Oh, innovation at its finest.
Y'all hear it?
Look at that.
Spatial.
From laser scanning to virtual reality, 3D models and other digital data captures are quickly becoming must-have technologies in our industry. Globally, ExxonMobil has spent tremendous resources on independent 3D efforts, from capture to creation, and even purchased visual assets. These 3D models help us gain better insights, make informed decisions, visualize disparate data, and streamline innovation. However, many of our 3D assets are stored in various locations and used locally when they could be leveraged across ExxonMobil facilities. As part of a company-wide initiative, we're establishing a digital reality ecosystem, which will serve as a foundation for our 3D visual assets platform. This ecosystem will help us capture 3D models in formats that everyone can use, centralize where they are stored, and automate the way they are delivered, so they can be used by anyone, at any time, from anywhere. This ecosystem will allow us to move toward a more visual way of working with contextualized data, which will be essential to our success for corporate scale and integration, now and in the future.
For the folks that have your camera on, Keep it on. We've got a QR code. That's how you reach out to us. Our inbox is always full, but we'll try to do our best to respond through DMs on LinkedIn. Ladies and gentlemen, thank you for your time. ExxonMobil has moved to a visual way of working. Thank you.
Thank you all.